At the BP station, of course. Ha, it's kind of a stupid joke. Anyways, guys, we're going to do distribution in equations. So we're going to talk about how to solve equations that require distribution. And your I can statement is to solve multi-step equations that require distribution. And let's get that written down, and then you'll have an idea of what that looks like here in a second. And in our agenda, we got to review some key terms. I do want these key terms in your notes. That's super, super important. Okay? And then we're going to do a few example problems, not a lot. All right, number clue real quick, coming at you from the beginning. It's one less than a prime number. So this mystery number is one less than a prime number. All right, so here's some key terms, and these are the things I want in your notes. What is distribution? Well, it's a math property someone discovered, probably hundreds, if not thousands of years ago, that 2 times 3x plus 4, where you have 3x plus 4 in parentheses, so you've got some kind of expression here, 3x plus 4 being multiplied by 2, is the same thing as 2 times 3x, whoops, my pen got all messed up there, is the same thing as 2 times 3x plus 2 times 4. So 2 times 3x plus 2 times 4 ends up being 6x plus 8. Okay, so that's what distribution is. Get this example written down in your notes. It's going to be important. You're going to need to know what this distribution is supposed to look like. And the 2, the reason we can call it distribution is the 2 is being distributed to both terms. Solving for the variable, what's that even mean? It means finding a number for the variable that makes the equation true. For example, x plus 3 equals 5. If x is 2, then the equation is true. So we solved for x by saying it's 2 because 2 plus 3 is 5. So that's what solving for a variable means. 2 quick example problems. Here are the steps. You're going to see a lot of problems like this, okay? And it looks hard at first, but it's actually not hard if you follow the steps. First, remove the parentheses using the distributive property. And I'm going to show you what that looks like. So I'm going to rewrite. Here's an important rule when doing equations. If you're rewriting, if you're simplifying an equation or doing something to an equation, rewrite everything in the next line that you didn't change. So I'm not going to change my 3x here. It's starting up here. So I'm going to rewrite it. But I am going to begin by distributing this 6 to both terms to do step 1 here. So 6 times 3x, a positive 6 times a positive 3x is going to be a positive 18x because 6 times 3 is 18. Plus, because it's a plus 6 times 14, plus whatever 6 times 14 is. So I'd figure that out, off to the side because I don't want to clutter up my work. And that's 84 equals, I didn't touch the negative 147 yet, 147. So that's the first step. I just use the distributive property to change this 6 times the parentheses into 2 terms. Now my next step is I'm going to combine like terms. Okay, that's step 2. So I've got some x's here I want to combine. So that gets me 21x. Now I'm going to write plus 84 because I haven't changed it, and I haven't changed the negative 147 yet. Okay, then it says solve for the variable. Now you're going to recognize this as a standard 2-step equation. So this is what you did, in the last video, in the last lesson. It's a 2-step equation. So I've got to begin by getting rid of the 84 from both sides through subtraction. And these cancel each other out. So I'm left with 21x equals, same sign keeping at, right? Negative 147 minus 84 is going to be a negative, whatever the addition of those things is. So negative 231. And then from this point, I need to continue to solve for x. And so this is 21 times x. So I'm going to divide by 21 on both sides. The 21s cancel out, so I'm left with just x equals what negative, because negative divided by a positive is a negative. Whatever, however many times 21 would fit into 231. And we can figure that out here. We can do the math. So 231 divided by 21. 21 goes into 23 once. There's 2 left over, bring down the 1. And 21 goes into 21 once. And then there's nothing left over. So our answer must be negative 11. So that's all there is to these, guys. I'm going to show you one more example. Then this is going to be, we're going to call it a wrap. All right. Again, the first thing we want to do is remove the parentheses using distribution. So I'm going to rewrite everything I don't touch. But this time I'm distributing a negative 6. Remember, we want to think of the number here, 6, in terms of the sign right behind it. So it's not just a 6, it's a negative 6. So it's going to be negative 6x minus 18, because negative 6 times positive 3 is negative 18, equals minus 28, or negative 28. So now I'm going to combine like terms again. 7x minus 6x is just x. Minus 18, I'm going to rewrite what I didn't touch, equals negative 28. Okay? And from this point, it's just really a one-step equation. So I'm going to add 18 to both sides to get rid of the 18. And these cancel out. So I'm left with x equals negative 10. So x must be negative 10. And if we were to check that, if we were to put in negative 10 here for x, we could do it in our head, and negative 10 here, but it'll be a little harder to do in our head. So if I was going to actually check it, I'd pretty much take this equation, plug in negative 10 for all the x's, and see if I get a true statement. All right, guys, you can do this. There's really only one extra step than a two-step equation, and that's distributing to get rid of parentheses. Best of luck to you guys. You're going to do great.